Yes, I did prepare a talk for this CLI, and I'm happy to be here. And I'm going to talk about what I found and my colleagues in Southern California have found is been rather interesting. We've noticed over the past 15 years or so that we have had teams, experienced teams that we thought are, and in many cases were, championship level contenders to advance out of our regional contest up to an NAC or even a finals, and found that they made surprising errors that we didn't think teams at that level would make. Hence the title of the talk. Really, they missed that. It was things that surprised the judges and started us thinking about, what's going on here in terms of what contestants are doing, what they're focusing on or overlooking, and what we can do and what we should do to address this. I mean, the bottom line is you have a regional contest, and it's not like an NAC or World Finals or another championship level event at a super regional level. I mean, first round regional contest, you have contestants at all levels. You have contestants that are contending for the championship and the right to advance, all the way down to first-time contestants at any competitive programming event who are potentially first-year students. So you've got the whole gamut. And given that you have that kind of gamut, you have a problem set that reflects that. You have problems that are presumably very straightforward, and then some that are a little more difficult, but still you'd expect the better teams to get them pretty easily, and then so on up the line until you get to the problems that are championship caliber. And with that wide range of problems, you figure, okay, there's going to be 2, 3, 4 pretty easy problems in there that the strong teams are going to, oh yeah, big deal, type, 10 minutes, done. Or sometimes even less. And yet, we would find on some of those problems, and maybe some that are just the next step up, that there were teams that made errors that we didn't expect them to make. I have a few examples of those here that I'm going to talk about and let people kind of think about, what was going on here, and in some cases the rationale for asking the problem to begin with, and things to think about in terms of potentially preparing teams, preparing students, not just for competitive programming, but for their entire careers. So I'll go ahead and start the first one here. And this is one where the fundamental issue is one, when you think about it, it's pretty clear, but an amazing number of teams didn't pick this up front. This was in 2018, 2019, There's a problem called backup orphans. And it was a list matching problem. The idea is that you have two lists. One is a list of backup image names. And those backup image names are arbitrary strings, 1 to 32 printing ASCII characters. Okay? And then with that, you are also matching them up against backup files for those images. And the backup file names are the image name underscore a timestamp, basically a Unix epoch in seconds, so 31-bit number, underscore an arbitrary type, full, incremental, or inker, user, whatever, just uppercase short string, up to 6 letters, 1 to 6 letters. So you've got a string, and then you also have string underscore timestamp underscore type. And we have an example there on the back one. Backup image directory A1, that's the name, underscore timestamp, Unix timestamp, underscore full. Okay, that's the backup file name. Okay, and you have to match the image names against the backup files. So, how did this problem go? Well, we had a 93-team contest this year. 34 teams got the problem right. And in those 34 accepts, there were also 279 rejections. That's a lot of rejections. Only 4 teams got it on the first attempt. And you know what the problem was in almost every case? They didn't realize that that 32-character string might have underscore integer, underscore name in it. It could. It's an arbitrary string. But, apparently, if you didn't work from the end to strip off the last fields, or if you were using a regular expression, anchor it with the end of string, with that $sign at the end, you'd fail. And a lot of people did. Oh, and by the way, why did I write this problem? And I did write the problem. Because this actually happened to me at a real customer. Not to me personally, thankfully, or to my company. But one of our suppliers had run into this problem at one of our shared customers and said, we'll write a routine. We'll take care of that for this customer. And guess what? They forgot that it could include that pattern too. And they ended up deleting customer data. Thank you very much. And not a good outcome at all. So that was kind of like, I wonder if maybe we should kind of reinforce that with our students. And that's what happened. So that was a kind of a practical lesson learned that we wanted to present out there. Oh, and we were amused at this last clarification request. This came in with 1 hour left in the contest. Is underscore a printing character? And it was like, okay, I think they're onto something. Whoever asked that they had figured out what the problem probably was. And it was like, okay, this is, this team, whoever it was, is probably now on to, what their problem was. But yeah, that really surprised us. Again, that first-year teams, second-year teams would make that mistake? Sure, we expect that. I mean, it's a fundamental analysis thing. When we're saying any characters, that's really what it means. But championship level teams making this mistake and only 4 teams getting it right the first time out, that surprised us. Because we really thought that the stronger teams would understand the implication of what that requirement really means and how you have to defensively code for it. So that was our first lesson. Well, actually, it was our second lesson. I'll talk about our first lesson, which is a little different here. This one goes way back. This is kind of the first problem that we ran into about 15 years ago, where we started thinking about people maybe not understanding things they should. This was a gambling problem, actually. It was called parlay wagering. It was actually a shared problem that we had with Mid-Atlantic, and it was proposed by the Mid-Atlantic team. This problem, the idea is that, imagine you're and we had to explain all this, of course, because we can't assume that students know how to do this, but assume you go to a sports book and you're going to place a bunch of sports bets, which is even more popular now than it was 15 years ago. And you're going to place what's called a parlay wager. And a parlay wager is you can bet on several events all occurring, and you put a bet down, and you win a lot of money if all your bets come in. But if any one of your bets loses, you get nothing. And the way it works is that you compound. The first win becomes the bet for the second, and if you win on that, your now larger winnings becomes for the third, and so forth. So they compound. And, oh, by the way, there's 2 things you have to know. Each wager, when you calculate the multiplier, you truncate it, not round, truncate to 3 digits, and the actual amount won is also truncated to the cent. The sportsbook, of course, pockets that little extra increment there. So here's an example of how that works. We have 5 money lines here. If it's a minus number, the multiplier is 100 over that number. If it's a positive number, it's that number over 100. So, $10 becomes $15.88, becomes $25.80, becomes $58.05, becomes $101, and you can see each one you get a win. And gosh, if you put that $10 bet down and all 5 of those bets won, you'd walk out of Las Vegas with $173.11. But those 2 critical things, the multiplier decimal, exactly 3 decimal places, and any additional digits are truncated, and the amount won each time is truncated to the cent. So, okay, this isn't a trivial problem, but it's still, get 5 bets, make sure none of them lose, and do these accruals. How did they do? 17 right, 218 wrong. 7 correct on the first attempt. And you're thinking, okay, so what seemed to be the problem? Well, the problem appeared to be mostly in the truncation. And yet, to do this truncation, a tremendous number of teams tried to do this using floating point values. That's probably not really the way you want to do this. You probably really want to use scaled integers. You could do it in Java with, big decimal if you wanted to. Or you could just use integers and manage the scaling yourself and do it in cents. Very, very few teams realize that's what you should do for this. And with that, again, that was a kind of a lesson. It's like, okay, people would try all sorts of convoluted things to try, and some of them even eventually managed to succeed. But yet, this very basic things of taking something where you have to have exact values and not using floating point to represent it seemed to be something that was lost. And in fact, afterwards, the judges made a couple interesting comments. One of them, the chief judge at the time from Mid-Atlantic, made the comment that the contestants apparently didn't realize that money and floating point just don't mix. Okay? And one of my colleagues in Southern California, who's also now retired from being a judge, has made the following pithy comment: one shouldn't be allowed to use floating point without a license. And, you just really, if you're using floating point, you really have to understand what's going on. And, there's rounding, and there's, the stuff that's base 2, so you're not going to be able to do decimal numbers exactly, especially with fractional parts. But people kept trying it. And it's like, really, you're dealing with money, you probably need to do it in some type of decimal representation, and that probably means integers. So that was kind of the second lesson there on that. We actually tried something like that again just 2 years ago. We had a problem we called the tontine confusion. A tontine is an investment pool where people can pool their money. Usually they're people of about the same age, because the classic feature of a tontine is that when people pool their money and you invest it, and then you pay out the annual income from the investment based on the shares they bought. But when somebody dies, their money goes to the survivors. And then when somebody else dies, it goes to the survivors, and the survivors get more and more money every year until the last person dies. And then the state keeps the principal. Again, truncate to the cent. In this case, the percentages were always 2 digits after the decimal point, and shares were $100. So, if you read through all the specs, you'd realize that you can do everything and should do everything in cents. Results a little better percentage-wise: 14 right, 69 wrong, 5 correct the first attempt. What I found interesting on this one, just in terms of a result, the first place team got it right off the top. First attempt, they got it right. So did the 10th through 12th place teams. They all got it right off the top. 2nd through 6th place, none of them got it right off the top. They all needed multiple attempts to get this one. Think about what the data are telling you and how they have to be represented and how computers represent numbers, and money and floating point don't mix. So that was kind of the lesson there. This third one really surprised us. This was intended to be, and it was, the easiest problem this year. This was in 21-22, so this was coming out of the pandemic. This was our first first physical contest back after having to do an online contest the previous year for COVID. So, this was intended to be a really easy problem. You read a 24-hour time, 4 digits, and you print out the watch face that looks like that using dots and asterisks with a blank in between, and blanks in between columns and a blank column in the middle. That's it. That was the entire problem. And that's, that was the schematic diagram for 1615, because you've got the binary 1, and then the 4 and the 2 make 6, and the binary 1 and the 4 and the 1 make 5. So that was the entire problem. It was intended to be very easy. And statistically, it was. 43 teams got it right out of 48. We only had 48 teams because we were only allowed to have half capacity after COVID. We were still masking up and social distancing and everything. 12 got it right on the first attempt. Well, that's not very many teams to get it right on the first attempt for what we thought was going to be a very easy problem. None of the 5 teams got it right the first attempt. And we thought this was a freshman problem. What's going on here? Well, you had to line up the vertical columns and you had to have a space in the middle. And that seemed to throw people. Now, I realize, we're not asking people to write reports anymore like we did 25 or 30 years ago. But we really thought 4 vertical columns with spaces in between was not too much to ask. It seemed to be. Yes, eventually all the teams got it right, but they were taking penalties needlessly, or we thought needlessly, on things that would be, very, very simple. The other thing that struck us is these days they get all the sample output in machine-readable form. So they had it right in front of them, what it was supposed to look like. If you did diff, you would notice that things didn't work out. And in some cases, it wasn't just a matter of like an extra space or something. They didn't have any space at all, so it wouldn't even match as a token. 2 dots is not the same as a dot and a space. So, it was like they didn't look. Nobody had bothered to check to see if this was, if they'd even gotten it right. Now, maybe in a couple teams, this is so easy, we'll just boom, 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 and got sloppy. Okay, but when it was, 43 right, 83 wrong, and only 12 got it right the first time, that was telling. So, the bottom line of why I'm bringing these things up, why I thought it was worth talking about, is I know, Christian and others are talking about, curricula, what should be covered. I know Etienne's going to talk about that when he's able to do his talk. It's going to be on Wednesday now, right? Is what kind of problems should we be asking and such. But yet, when we see strong teams making basic errors in understanding requirements and just checking basic things, are we overlooking something here? What's going on? And I don't have an answer to that, but I wanted to bring this up because I wanted to bring up that discussion of what could be done and what we have seen, and in some cases what we've seen multiple times, and how we should potentially address those kinds of issues. I certainly don't have all the answers, but I do have, wanted to get this out there as a discussion topic, which I'd be happy to start right now if anybody has any questions or comments or anything. Or not. Yeah, okay.
I guess for every presenter, actually, I have a ton of questions, but I'll try to limit it to, I think, most relevant one. So this one, what I'm wondering is, the future direction, I think is going to be a topic for Etienne as well, but really for people who are longtime veterans here in the audience also, I'm wondering what's the direction of the problem that you would like to actually set, in a sense that, do you care about the let's say, formats and formality of the question? Is that really one of the problems that we want to try in the regional level? Or is it really that we want to try this in the, in the top level of the contest also? Or do you want to, let's say, forego of the formatting issue and really focus on the core of the actual problem solving? So the core is, do you care about formatting? And if so, to what extent? And then maybe follow up to that is, what other topics do you think in your mind would be something that we should focus on?
Well, we certainly did. We're not, as I said, we're not looking to write reports anymore. We're not looking for that kind of stuff. 30 years ago, if you look at those really old problems, you used to see a lot of that. I think that ship pretty much has sailed. But when you threw what we thought was a softball out, basically, it was a very easy problem, and that wasn't, and then we get those kinds of errors on it. It's like, okay, seemed a little concerning because it seemed just so basic. As far as the other problems that I think are relevant, certainly things like understanding the limitations of floating point, I think, are very relevant, and it's something that probably should be pursued, and certainly understanding the ramifications of requirements when things can be, an arbitrary string and then not matching a pattern or not matching, and then making assumptions that aren't warranted on that. I think that's something that probably should always be focused on, because that's something that's always going to bite you no matter what, and that could be in any context. So that's that's where that's headed. Yes.
Yeah, I was just going to say that in my experience, I think there's just certain things, like humans work a particular way, and it doesn't matter how many times you teach people about floating point being imprecise. Like, I've done it, over and over and over again, and still, I think a lot of it is the heat of competition. Some students are really calm and are able to really slow down and carefully analyze things, but a lot of students will revert back to their natural habits. So that, every single time I've ever seen a problem where you're supposed to avoid floating point, I think I've seen the results that you've seen, and I think that's typical. And then I think with the underscores, I think people assume, well, you would only choose the underscore as a separator if it wasn't in the original string. So it's like, that's what people...
And yet that's not true, because in many cases here, you'd be looking at a situation where, what if you're backing up a backup image?
Yeah.
Which is absolutely valid.
But yeah, I think a lot of it's just kind of how the human mind...
Well, and that may be true, but that's one of the things that can come back and, bite you if you're not paying that attention to that. So, and that's kind of what we wanted to convey there.
Yep, that's a really good thing that he mentioned regarding that stuff. Sometimes I solve questions and I face the really same issues. And after retrying, I came back solving the problems because I know, for example, test cases. But I would like to understand some of the things which are out of context. So you mentioned that some of the strong teams can solve it in one try, and some teams need to retry it in order to understand the problem. And the main thing, what do you suggest, or what do you think is primarily problem of these teams underestimating these easy problems? And how have you ever noticed that how it is affected they morally? For example, they couldn't solve that problem and they could fail at solving other problems in the contest.
I think I'd like to open that one up to the floor almost a little bit and see if other people have an answer to that. I haven't been in the I haven't been in the university in 30 years. I've been in the private sector since the early 90s. I did start out at the university, but even then I wasn't a faculty member. I was on the professional IT
the question
side,
will be just looking to the requests that they make. For example, they fail at that problem and they cannot solve other problems as well. I'm just
is this a harbinger? If they miss on this one, does it mean they'll fail on other problems?
Yes, because they morally couldn't solve the easy problem, and they think that, okay, I cannot solve the other problems as well. So, based on your findings that you saw that, okay, they tried this question.
I could go back and look at the statistics from those other contests, particularly this one, and see where that went, because you're right. That's one where, a third of the teams, a little more, 93, 31, 34. So a little over the third of the teams actually got it. And I could go back and look and see, and it's a valid question, how many other problems did those teams solve, especially those that had 3, 4, 5 rejected attempts on this. And does that, if you're asking, is that demoralizing or whatever, I don't know that it is necessarily, but certainly I could see it like, gee, this doesn't seem like it should be that hard. What's going on? Is some of it the heat of competition? Probably. But when you start having, things like that are very fundamental in terms of requirements analysis and understanding, hey, this could be anything. This is a pretty clear end case. And one of the things we do teach when coaching teams is to think about the end cases, right? That's one where, I think there's definitely, potential lesson to be learned there, especially on this one, since that was one that definitely, to my mind, was like this pretty clear end case that you need to think about. And that is something that you typically teach and coach for in coaching programming teams. Anything else? Yes. How am I doing on time?
Thank you for the speech. My question is as follows. You are speaking about coaches who should presumably do something about their students and teach them not to oversimplify the problem statement. But I'm interested in another perspective from the point of problem setters' view. So my question is, should problem setters do anything not to make contestants oversimplify their understanding of the problem? Because sometimes, as a problem setter, I encounter this reaction of contestants that they complain that they felt that there were some caveats that they thought problem setters wanted contestants to fall in. Yeah. So
walk into a trap kind of thing.
Yes. So this problem about those file names, I think is one of those examples of those caveats. Maybe not so explicit, but still. Yeah. So my question is, should problem setters be more open to revealing the caveats in the statement, or it is solely the responsibility of participants to detect these caveats?
Well, I think that's an open question, right? To my mind, in this case, I thought the way it was stated was fair. Okay, are there cases where people have made more hidden traps, if you will, or tricks that if you didn't see them, you would likely run into problems? I don't know. As I said, I don't have all the answers here, but I wanted to at least bring up the discussion. I didn't see a problem with this one personally. I thought the string one was fair, that any means any, and that you have to consider that. And again, it happened to me in real life, so that kind of reinforced that. And the floating point thing, kind of the same thing. You need to understand, as you said, you can teach it several times and people still, that's pretty core, I think. So, yeah. But again, I think there's certainly room for discussion and fair discussion about what is and isn't appropriate.
Thank you for the answer. Just from my perspective of ex-participant, I used to see that there were more of those problems earlier that contained those caveats and tricky statements. But now in my super region of ICPC, in particular Northern Eurasia, problem setters more and more came to a conclusion that statement should be as clear as possible, because because due to quite obvious reasons, because not to confuse participants and make them think of the problems themselves, not of the caveats. But yes, I was wondering about standpoints of other regions, because this is, yeah, of course it's an open question, but I wanted to like discuss it with other problem solvers.
No, and I'd encourage that discussion, because I think it's an interesting topic. I think it's a very valid topic. So.